In this short video, we will show you an example of a protein-ligand complex modeled in SeeSAR. This protein-ligand complex contains a so-called magic methyl, and we will use SeeSAR to understand the binding situation. When you open SeeSAR, you see this splash screen. You can either download a PDB from the PDB website, from your hard drive, or you can also use SeeSAR in ligand-based fashion by simply loading a molecule and editing it. The PDB code of the complex we will be studying is 3IPH. It's a P38 Map Kinase. And when I type that, SeeSAR pulls that PDB structure directly from the PDB website and calculates the affinity, the estimated affinity for each of the ligands co-crystallized with the protein. We can see the ligand co-crystallized here inside the protein 3D structure. Each of the proteins, you can load multiple proteins, is shown in the protein section of this table, and the co-crystallized ligands are right underneath. The ligand in question here has an experimental binding affinity of 25 nanomolar, so this is in very good agreement. You can see the 2D structure here, and this is a ligand that exhibits a so-called magic methyl. So in order to view this, we need to determine the binding site for this. This is 3 mouse clicks. And we need to bring the ligand over to the molecules tab over here. So now we can calculate the affinity again. As we had seen before, the affinity was in the nanomolar range, which is again in very good agreement with the experiment. And now we can study this molecule in the binding pocket. This is the surface. We can make the surface transparent so we get a better view of the binding pocket. It's a pretty narrow pocket. And let's get rid of the 3D structure. So this is our ligand here. And we can see that there is a methyl group which contributes a great deal to the overall affinity. Each atom on the ligand bears a so-called affinity corona that shows by color and its size how well or bad this atom contributes to the overall affinity. Green color means the contribution is good for affinity, and red color means the contribution is bad. It's a penalty. And the size corresponds directly to the amount that this atom is contributing. So we can see that this methyl group here, that's the magic methyl, which contributes with 7.1 kilojoule per mole to the overall affinity. At the same time, we can also study the conformational quality of the ligand, and that is shown here. Each torsion is color-coded according to how well the torsion is represented in the CSD. So green means very well represented, yellow means occurs occasionally but very rarely, and red means never occurs. So let's see what happens when we remove this magic methyl. So we can see two things. We can see on the one hand that the torsion between the rings is turning to red, which means that this torsion is never experienced in small molecule crystal structures, and we can see that the estimated affinity is decreasing by about 1 order of magnitude.